All right, let's give this a go.
All right, we're pulling it audible. There we go. Okay, that looks good. Okay, go ahead, Huy.
But all right, I will change the slide when you tell me.
Perfect.
Yeah.
Okay, we'll go right to slide 2, and Huy, you want to go ahead?
Yeah.
Thanks.
So we are engineer, and we want to automate things, right? We want to build tools that user can use very easily. So in our use case, we want to spawn up VMs on demand, and it needs to be automate, and the demand is high. So let's say we spawn up like 100 VMs at a time, and so right now we need to the automation is querying API server 100 times to request 100 VM being created, and that's repetitive. And let's say we only want to spawn up identical VMs, then it will need to prepare 100 identical VMs, and to create a VM, it needs to going through a lot of steps to preparing VMs, preparing VMI object, and preparing the pod. It's going to update the VMI spec, label it, and adding conditions, prepare data volume, set up metadata for VMI, and prepare pod templates. And that informations are the same if we're using the identical VMs. But our case is different as we want to have a specific data per VM, and we don't require the VM to last long. It can be ephemeral. So we're thinking maybe coming up a API like Kubernetes Jobs should be useful. So I will share my. Can you go to the next slide, please? Hello. Oh, yeah. So let me share with our investigation. So we think that VMI replica set can fit into the picture here because it can allow a user to spawn up to request the number of replicas. However, we have some drawbacks that we decided to have another tool for our use case because we need the tools that we can decide which VM to scale down, and VMI replica set want to maintain the number of replicas instead of letting us pick which VMIs to remove. And secondly, each VMI is injected with a specific data, so we want to have control. We want to have control of the specific instance. And third, we dig inside the implementation of VMI replica set and found out that it used the VMI API, which repeat the process of preparing the pod template and VMI template. However, we realized that we can share the common template to cut down the repeating step to provision the identical VMI. And we find that the need to have a CRD that's similar to KAS job to simplify the number of steps and API calls. The API should be easy to use and let the user remove the specific VMI instance. So Ryan can talk more about our ideas in the next slide. He will share a document and he can take over it.
Cool, thanks, Huy. I'll share the design document in the chat here. It's also on Slack. And can you switch over to it? you get the chance, David. And so thanks, Huy. So kind of introduce the concept and what we're looking at. The general, I'll reintroduce it. Like we want to create hundreds of virtual machines, and what we're going to end up doing is we have lots of API calls that we do can get repetitive. So it seems that Kubernetes has sort of a similar way of dealing with this kind of thing with their batch API with jobs. You can create a bunch of pods, you can create them in parallel, and it will just launch however many you want. It's nice, and it has some features like if you delete the job, it'll clean up the pods. So there's sort of an attachment. And also, you can delete the pods individually, and the job isn't necessarily going to go and create more. It's just sort of like this very light attachment to between them. And so there's sort of an example. Yeah, thanks for pulling up. That's out there. And what's interesting is so you can see AWS has this called Fleet. And some of the things you want to highlight in here is okay, you can have, say, in your fleet, you can launch a bunch of VMs and you can do overrides. So if you scroll down a little, you can actually see in that picture there, there's like a C4 large and there's sort of a capacity for it. And then a C5 large, so different types, things like that. We can have sort of the control over, we want to launch this many VMs and they want them to have these overrides. So there's like a little bit of templating, as well as being able to control a large number, like a do a bulk request within a single API. So that's kind of where we are and what we're thinking. So to kind of kick off the discussion, I put one idea into the design doc as a way that we can look at this. So we scroll down a little to the virtual machine job. So I even kind of highlight this a little bit. So the differences between, let's say, a Kubernetes job and a virtual machine job. First thing, a non-parallel. So all the highlights in blue are sort of things that would differ between the two. A parallel creation of jobs as opposed to virtual machines. A fixed completion count. Pods, so the job will look for a completion. For virtual machine, we could define completion maybe a little bit more to be a specific phase, something like running, I was thinking. Things like templating, something like that, be the same. Job owns all the pods it creates. Instead, we go on the virtual machines. We have some sort of wait for conditions, and then we're going to sort of wait until we've reached the allocated amount. Uniform metadata, this is a requirement for jobs. Virtual machine, we'd probably want to have some unique metadata or user data, like cloud init data. We want pass secrets, passwords, things like that. We could see it being the case that you need to have unique metadata. So if you scroll a little farther down, I have an example here. This is just sort of just a general idea. There's already the virtual machine API, which sort of serves as a template of things. And the general idea here is that I was thinking, okay, we have this virtual machine object. What if you were to sort of reference the virtual machine object and say, I want a certain number of those, and then maybe I do some overrides of them. So you have 10 of those number one VMs, and we're looking for having them in a running state. And then we have 10 of those number one VMs in parallel. We change the memory. Then maybe we have 50 of those number two VMs with some unique, cloud init data, something like that. And maybe those virtual machines created as well as the virtual machine instance being spawned with them. So sort of having that kind of relationship. And then at the bottom there, I kind of have if you were to do a get of it, here's some of what it could look like 10 one VMs, and you can see them in running, something like that. So I wanted to just kind of turn it over to anyone that has some thoughts about this, and we can kind of record them and see what people think.
Yeah, I have an initial thought. So I think one thing to kind of clarify would be what are functionally, I know we went over this, but I think it would help with the conversation, the differences between what's trying to be expressed in this virtual machine job and what we have in the VMI replica set today. So VMI replica set's always trying to reconcile X number of virtual machine instances. If you take one out, and it's going to spin up another one. And the job, if say you want 10 in parallel, what would happen if we manually like shut down one of those virtual machines? What would you expect this virtual machine job abstraction to do? Would it replace it, or is it saying that it's completed, or yeah, what's the thought there?
So in the way that we're using a job, it wouldn't replace it. There wouldn't be, there would be very light linkage between sort of the job object and the actual virtual machines themselves. So like I said, it wouldn't be created that you could have control over the individual virtual machines and you can do whatever you want with them. The only control would be that if you were to remove the job itself, then the objects, the virtual machines themselves would be removed.
Okay, so in we'll just take this one that I have highlighted right here. You said parallelism 10, so we're going to get 10 of these virtual machine instances. Let's say we spin up all 10 of them and the job still exists, the virtual machine job still exists, and I delete one of them. So we've declared that we want 10 in parallel. Are we saying that it's okay after we've reached a certain condition, if all 10 have been created, that somebody could go in and begin deleting ones that may have been spun up by this job and the job would not replace them? Or are we saying that the job is not in a reconciled state if we do that? That's kind of, I know I'm asking the same question twice, kind of, but I'm just trying to kind of drill down a little bit.
So once we reach the sort of the completed state, the job is not going to be exercising any more control over the underlying assets. There will be, we've reached 10, now we're not going to be reconciling it at that point.
I see. So there's no ownership, really. Yeah. Okay. At that point, it's a completed.
Yeah, very light ownership. Only, yeah, we have a completed state. After we've reached it, we don't really care about them anymore and what they're doing.
And would you wait there for the VMs for, I don't know, a ready condition or something until you say, okay, now I consider it created and I would not create a replacement, or would you not want to create a new VM instance at all?
Go ahead.
Yeah, so as I mentioned, we have specific data inside VM, and if the VM corrupted or if we want to remove the VM, it should not reconcile. So that's the use case that we see. So if we spawn 10 VMs and we want to remove one, then it should be 9. It shouldn't reconcile back to 10.
Okay, so you really want let the controller create 10 VMs and then just monitor, but don't do any action at any cost, basically. Okay. One question with, or maybe someone else. I have to reformulate my question. Maybe someone else wants to continue.
Well,
there's a question in chat, which I think is good. Is what you're really aiming at a batch start job or more of a VM pool in the end? So a VM pool is something that is definitely something in the area here. And this is, I guess, maybe like the discussion between like the replica set. And so where we kind of landed on this is like, what is sort of the fit for a VM pool? Because I guess you could say that's sort of what we're after, but what's the right fit? And it was like originally that's where we started kind of with the replicas. We didn't quite find, for the reasons we mentioned, that it fit exactly what we were looking for. And so this at least isn't the perfect fit, but at least gives us the opportunity to get what we want out of it. So sort of having that flexibility, that control, granular control of the virtual machines after they get created. So we can sort of make it into a pool, like a pool, if we wanted to, with sort of maybe another abstraction on top.
one more question on this one regarding the difference to pool and job. Let's suppose you create the 10 VMs and 5 of them are shut down, and it goes on, and maybe at the end there is only one running. What would be the trigger for you to create more VMs then? Like, would you want to, outside of this controller, then monitor the overall situation of how many VMs you have and then create another batch when you think the time is right? Or what is there?
Yeah, that's right. Yeah, that's right. So we monitor the count. So that's how we sort of reach this idea of a pool, is that we'll monitor the count and we'll always know, okay, like that we're not at capacity right now and we know what we want to reach. And so we will reach it. So we're missing 5. So we'll launch another 5.
So I wonder if, I see why the virtual machine instance replica set is not a clear fit. And maybe also not a pool like it is. I wonder if you did consider some kind of a mixture with maybe, I don't know, something like a VM pool or virtual machine deployment, where you can have a special condition or something which you can somehow fill from the workload, which can say, okay, now I'm done. I'm not useful anymore or something. And combining this with something like horizontal autoscaling with the Kubernetes primitives?
Well, will that get us sort of the uniqueness sort of at the pod level and sort of the control that we would need, though?
Well, another question then. What is the uniqueness in this case? You say you have a virtual machine job. You say you want 10 VMs. You pointed to one VM, it seems. It's called 10 VMs, the name, right?
Yeah.
And then you overwrite a part of this VM. So you get 10 VMs which look exactly like this, right?
Mm-hmm.
You don't get 10 VMs where everyone has individual data. There are 10 identical ones. Or do I read that?
Yeah, no, that's correct. So what is sort of this is good to expand on. So what I'm thinking is that I think the second one, like 50 number 2 VMs with new my cloud init data. So in this case, the idea would be that we would have some sort of secrets that would get passed, but it would be a unique secret for all of them. So whatever it is, like we'd have to, so the templating here is that, okay, there's going to be some sort of secret override, but whatever it is, it could be unique. So like in this case, something that matches a label, a secret with this label will be handed out to all these virtual machines. And there could be many that match that label, so they will all just be individually handed out to those virtual machines.
Okay, this would be an implicit property of the virtual machine job controller, or
yeah. So it would sort of, so we have, so like I think this example said 50 VMs. So in this case, we have 50 secrets with some sort of label. We then do the override and say we're going to hand out 50 secrets. Each of them will get a unique secret from this list of secrets and these that have this label.
But
so that can give us sort of that
sorry for asking again, but in this case, all 50 VMs would have the same secret, or would there be 50 secrets created with different content?
There'd be 50 secrets with different content. All could have the same label. And
the secrets are pre-created outside already, and you somehow attach it. And I guess I personally am missing a little bit information on this part, on how this would work. So on how, for instance, from this virtual machine job, the VMs would find the corresponding secrets.
So this is where, so the idea would be that some controller that that's dealing with this virtual machine job would be able to recognize this override and would understand that I want a secret. I don't say it here, but like if it had a label field for the override, excuse me, and the label that it called to was called it 50 unique secrets or something. And I have 50 unique secrets. They all have that label. When I start the one of the virtual machines, they'll be given one of the secrets with that label, and so on and so forth, all the way through 50. And so they'll all end up with a different secret. And each of those secrets I created beforehand, they all have unique data.
So there is one case in Kubernetes on deployment on stateful sets. Maybe that resembles Stadia pretty well. Just to clarify, there is this case you can specify on the stateful set the PVC template, and it will create the PVCs for you, right? But only if it does not already exist. Like in this case, you can tell upfront what the PVC names will be. And so it will then just automatically pick it up if it already exists, like, I don't know, PVC1, PVC2, PVC3, and that will correspond to the created name of the pod. Is this kind of the direction you're thinking about?
Yeah, that sounds like it. Yeah. So the sort of getting that uniqueness for some of the pods or some of the VMs.
Okay, I think I understand this better now. Thanks.
Okay. There's another question. So kind of what Agnes, I don't know what that is doing for game servers on Kubernetes. You spin up a pool of X VMs, and you'd want to claim them from the pool to own them. So the pool does not manage it anymore. Yeah, so very similar. Yeah, so it's a very similar idea. A lot of what I guess that I'm trying to like nail home is that what's like the Kubernetes way of doing this, like and sort of applying it to a virtual machine. I'm trying to follow the sort of the replica set model, and like Kubernetes has replica sets, so does KubeVirt. So what is like the Kubernetes way of doing this in KubeVirt, and to get to at least a lot of what we're after, with a few little tweaks, like the unique metadata, I would say is one of them. Yeah. Let me check the chat if there are any more.
Yeah, what I guess. So good questions indeed from Kevin. What I'm missing here a little bit is this point on what I see very often in Kubernetes is that you have a very clear purpose, like what Kevin is describing here, and then you're implementing all those parts in Kubernetes so that Kubernetes does all the work for you, so that it does not just create 50 VMs for you, but like that you have this explicit controller, which can cover your use case in the sense that you say, okay, here I always want to have 50 spare VMs, and you can, for instance, then take them out and use them, maybe, I don't know, by relabeling or whatever. And based on horizontal autoscaling or just based on the number on not used VMs, I will replace the gun ones so that you always have something to pick from the pool. But maybe you just pick, right? And then, I mean, you can do with them whatever you want. You can shut them down. In the meantime, I have already created a replacement for you so that you never run out of fresh instances. So that would be, for instance, from my perspective, a fully closed feature. Let me put it this way. I'm not sure if you understand what I try to get at. Compared to, in this case, it's not entirely clear to me. It looks like only a little bit automated, not really taking the full feature into Kubernetes, like just batching API calls and not really actually addressing it. The full use case.
Yeah, it doesn't address the full use case. Yeah, I do agree with you, but this is where no. So I'm open to addressing the full use case, but sort of finding the right balance is, I guess, the problem I'm having, and sort of would like, and I'd be open to having a question if we want to say like that KubeVirt wants to develop a virtual machine instance pool, for example, kind of API object. That would be really cool, and definitely be interested in discussing that if folks thinks that's something that would fit. It seems awfully close to a replication controller with some nuances, so I wasn't sure if that was the right way to go with this. Job seemed to be a little bit more closely like it could extend.
I think we could get first off, we're really close in time. We have like a minute. I think we can get pretty close to the behavior you're wanting with the idea of a pool. We just need to give it a little bit more thought and take into account the use case you're trying to achieve and try to see how the pool could be shaped to do that. There's enough overlap that if we're already considering a VM pool, I'm not sure how we could explain the VM job and the VM pool both existing. Anyway.
Yeah, I think they're sort of. I think a pool in terms of virtual machines, I think it probably makes more sense. It's just a matter of whether or not, like, if that's. So I think if we want to pursue the pool, I think if it fits what, like, if we have an API that sort of fits in a Kubernetes-like way, then yeah, I think that would make more sense.
And I'm sorry to step in, but I believe we will have to, I'm afraid that we will have to continue those discussions beyond the summit because we are already on time for the next session. So at this point, I would like to thank you, Ryan and Huy, to lead the discussion and introduce the discussion. But and thanks, David and Roman and everyone who participated. But I would encourage you to follow up after the session, probably through Slack, and most likely also to KubeVirt, the Google group, and communicate there. Okay?
Yeah. Thank you.
Thank you very much.